Thank you, Daniela, and welcome everyone to this webinar where I'll be running through some new FME features, including AI and data virtualization, and how they've been used to create a database, as well as connect this database to some other tools. And I do apologize for the quality. I don't have my headset at the moment, so just have to do it through the microphone supplied. Firstly, just a little bit about myself. I'm an account manager here as well as a pre-sales consultant. My background is in environmental science as well as GIS and remote sensing. I've been at One Spatial since 2020 and started using FME not too long after, but before that I was in just purely sales in the hotel technology industry. I'm now based down in Melbourne and I'm certified for both professional and business professional. Just quickly, I'll go tell you about the agenda. So I'll explain those two features from FME 2025 in case you just haven't done the update or you're just not quite across them yet. I'll go through the use case in which they're applied for, which has been done over in our head office in the UK. And then we'll go through the two components of extracting and building the database, which is where AI is used, and then also accessing the database, which is done by data virtualization. And just first up, we'll go through those two features in the new release. So AI connections, they're transformers that have been customly built and available in FME Hub. You have a selection of AI providers, and this essentially enables the best suited choice for what you're trying to do and using the right AI connector that they have. And an advantage of doing this is that you can build prompts dynamically in the text editor within the tool, and you can use your own attribute values and customize the call according to what data that you're putting through it. So some of the the AI connectors that are available, there's a few from OpenAI. So like AI Vision is really good for text, for imagery, I should say. And then you've got Azure and Amazon Bedrock and a couple of others as well that you can access. This is an example of just one that I have with OpenAI, so it's pretty consistent with the other web connection interfaces where you just are filling in the API details and your authentication. So with data virtualization, just diving into this for a slide, it's a graphical method of creating custom API endpoints. Long story short, which is done in FME Flow and is provided as a function in the interface. And the big benefit of this is that this is not something that's never been done before. It's just you had to do it typically in Python and script it up. So now you've got a graphical way to do it, and it's just a bit more manageable in that sort of sense. And it's essentially delivering JSON data into a JSON schema that you determine. And then that's how it's read by any application because it deals with JSON, assuming it has API capabilities, of course. And there's two advantages of this essentially. One, it means that your integration goes beyond just the formats and the databases and web connections that are provided to you in Form, and you can now extend that to any API. Any API that exists within any application. And you can use then the power of FME to manipulate data coming in that's been submitted, or additionally data that's been requested out. So I'll just show you what that workspace looks like. It's quite different, and you'll probably see the get tag in the reader. So essentially you're getting the API call in that's coming as the reader, and you can see query status in that annotation is coming in, and it can be different values that the person submitted as part of the GET request, which is then going through and put into a test filter to then determine how the request is handled. Then what we've got here as well is at the very end where you need to start creating the response codes, with the 200 response code being a success. And you can see the JSON templater is creating that response by formatting it in a JSON. And when it's providing the flood events that match the status, you get the severity, the location, the ID, and a few other attributes that you can see there as well. Now on to the use case. where we are extracting text from London commemorative plaques. Wondering what plaques are, or these commemorative plaques? They're these plaques that are put around as a historical sort of significance for different figures in English history, or people who have had something to do with the country or have lived there, or something like that. They're quite condensed in London, specifically the West, but you do find them around the UK, and you can see sort of in the centre with David Makata, I assume that's how it's pronounced. You've got City of Brighton down in the south, but then a lot of them are from the London City Council and City of London and things like that. And you've also noticed that they're of different geometry, throwing a few curveballs into managing how they're detected by AI as well. So we'll go through that a little bit later about how this is all handled. How the UK collected the data for the use case. Their mobile phone taken photos across the summer that Ian's gone around and collected the photos. And the good thing is that using his Apple phone, there's actually geocoding embedded in the metadata, which we can use FME to pull out and extract and turn into point data. The text extraction is performed by AI connectors, and then the text that's pulled out is used dynamically to name the features, which you can set from an attribute within FME, which then you can export as a KML, which is perfect for Google Maps and putting onto their base map. But then, of course, as well, the data that's pulled out from AI, along with the image, is populated into a database. This is just an example of that Google Map KML layer, and you can see that they're all dynamically being named according to the plug name. Highlighting the process in 4 steps of how this use case goes. We start with the Dropbox, which is the repository for where the images are uploaded. These are then identified or pulled into a workspace and then identified by AI with the text extracted and then cataloged appropriately. Then we go into the data virtualization side of this and we start building the APIs that we then feed into the into applications that we're going to integrate with that fits the mold of what these applications are designed to do and the information that they're pulling from the database. This is the start of the process where we're extracting the photos from the Dropbox. So we do that through an FME automation in Flow, and we start with the trigger, which is looking to a Dropbox directory. So when the new files are dropped in and they've been polled by the automation, they are then passed through into an FME workspace, which you can see in the next purple box. And it's got the writer feeding out into the next workspace where the image extraction and the image processing happens. It says Dropbox downloader, but what's actually happening here is that it's just pulling in the file path, I should say, from the Dropbox, because the file path will have the image type at the end as the file extension. So I'll show you soon, but it's actually the file name that's getting fed into the main workspace, which is used then for the photo conversion and the image processing. This is the main workspace that's been referred to in the FME automation that you just saw. It's not too big, but there's obviously a fair bit going on here, and there's some typical sort of transformations, manipulations that apply to certain data streams, but it's broken up quite well into 3 components. You've got loading in those files from the Dropbox and converting those to JPEG formats. Then in the middle, we're using the AI services to extract the plaque information, validate the plaques, and start putting that key information into a schema. And in the end, we're starting to prepare the information into the correct attributes for them to write out into the SQL database. The spatial database. And what I'll do now is I'll just go through the key parts of each of these components that explains what's happening, or the key processes in the workspace. First is the JPEG conversion that's happening at the start. The parameter fetcher is the big part here that's actually pulling in the file path from the Dropbox and turns this into an attribute. And now that attribute value can be used as a mean of filtering based on the image file type that's at the file extension at the end of the file path. It's the test filter that then takes this, and we can test for the values of the file extension, and that those different data streams then take on their own processing and their own manipulation to get it in the correct structure that we need. One of the key ones here is actually the iPhone photos, because the format for them is actually not a JPEG or a common sort of photo format. So it's processing those as well and making sure that we can convert it back into the JPEG, which is saved into the FME flow repository. And once that's done, we reread that in as a JPEG and put it through a geometry filter. But that rereading in means we can expose metadata such as the location attributes. And this is just a screenshot from the workspace at the start. That's just showing how a creator is able to initiate the workspace, but the parameter fetcher is where we can pull in that file name and extract it and use it as a test filter as a means to process the data appropriately. The next key component is the plaque recognition and bounding box, and I also show off some of the good features for the FME OpenAI or just the AI connectors that are in place. So what we've done first is to use OpenAI connector to essentially determine if the plaque is a plaque or not from the image going through, where we say create a contains plaque tag, whether it's yes or no, which we then use to filter out plaques that are not plaques. Following that, the Google Vision bounding box creator is then fed with the images to trim it back just to the plaque, and obviously that's eliminating a lot of the noise around the image, but it's good for thumbnail creation as well. And we actually test what the best bounding box was as well, which I'll show you a little bit later in the webinar. And what I'll show you on the right is what's used in the OpenAI connector that we did for text extraction. This isn't the prompt, it's actually a feature called structured response. And you can see that you can set your own schema for the information generated in AI to be outputted as, which is really, really good for flattening and essentially creating a repeatable process for multiple different features that are going to go through your AI connector. And as you can see, we've done here, we've made it quite detailed and included things like the classification, confidence, and things like that before. Once this has then been, the AI responses come out into the structure that you can see here, it's flattened into the data streams, and we create those attributes you can see there, like the content and the various sort of sub attributes you can see in there as well. Location, the metadata, and the category, which is the organization that implemented the plaque. And what we've also done here as well, we've just written it to a local file in a OneDrive with the thumbnail included, and the folder is structured dynamically by the category, so whoever made it. I'm keen to show you what we did for the AI prompts and building that, because obviously that's so critical to the information that we're going to be getting. We've utilized both instructions and prompts to try and get the best answer and train the AI as well as we can. The instructions we've structured in a way that we've said these are the aspects of the plaque that you need to be extracting from the prompt that we feed you. And then this is the actual prompt as well. So it's just basically do this, and for each plaque detect these that we've outlined a little bit in the context as well. And this is a really good process that we've done here, just to separate the context from the prompt so it fits how the AI works better. And the good way of, and why this has been emphasized as such an important part, is that you're eliminating a need to refine the response with additional calls. And obviously that's not something that can be really done within a workflow, because it's supposed to be automated and you're not really touching it, but it is still important, and it just means you're not getting garbage coming out, and makes it repeatable for future photos outside of what's already been dropped in as well. Within the AI connectors, you're allowed to edit the temperature and essentially the amount of randomness you allow in the model, and allows you to essentially test and test different values to see what's best for your use case. So within the Gemini, they've tested just a few ranges and a few different parameters and plotted the results over the plaque that we use it on. So it's quite a good step in terms of providing context for your results or ensuring that you're using the best available tools that you have. What they've also done as well, just to sort of prove that the system works and there is a bit of validation and legitimacy to it, is that they put in some red herrings. So you can see that, a lot of the logos are circular or might fit the sort of geometry of what the plaques would be, including some blue ones and trying to fool it. But it's done a pretty good job in picking those up. And an additional thing that the UK have done as well is that they've set the file path to be a function of what the feature type is, or essentially the category. So in those processed plaques, you would also have City of London, London City Council, the different types of categories, and then also invalid images, which is what they'd been sort of data streamed off to. So it's a good way of capturing. It's doing a good job of capturing the errors, I guess I should say. So now moving on to the data virtualization part and how this works with the tool, which is what you can see in the background, is definitely the more interesting part of the webinar, I would say. And I'll explain within that how the functionality works within data virtualization. Very quickly, just going to go over data virtualization and some of the finer details that will make the rest of the webinar easier to understand. It's just going through the interface and showing you how it manages all the endpoints that you create within FME Flow. So this is an example of the interface. So you can see at the top, which I've just got in the purple box, there's your endpoints, which is down below, and you can see which ones are gets and which ones are posts, and it's got the URL there as well. And along with that, you've got the schema tab along with the workspaces. The workspace I showed you before earlier in the webinar that had the get reader, and the schema is where you can build your status code, so bad requests, okay, and those sort of things, and set the data types. And this is an example of what we're using in this use case, where one of the requests is geared that a PDF report of the plaques are generated, and then a URL is saved to the FME Flow resources, which has a URL, and that's included in the request. So that's what goes through, so they can see a PDF report. As I said, I'll show you what that looks like in a little bit. Additionally, some sort of nice stuff, you can add tags to sort of group things, and the API details is really handy to give some documentation, but also test those endpoints rather than having to go into the workspace. So now I'll run you through what this database is being accessed for and the web tool that's visualizing and making this consumable. It's a website, and it basically is just acting as a front end to request the plaque information and location that we've just built in the in the spatial light database. There's a street map used as a base map, and then the endpoints, as I was just saying, that's created in FME, are called by the website and is embedded in the search box parameters within the tool. The schema in the endpoint is built so that it reflects the attributes built in the spatial light database. So you remember it was things like category, install date, all those different sort of attributes we're getting AI to create. So the schema, as I said, in those endpoints are just built that way to reflect those sort of things. It's one of the benefits with data virtualization. And the website building skills, I guess, the non-FME parts can actually be the main determiner in how well this database is sort of accessed, and those sort of things is what I'm trying to say there. And I've just got a screenshot here of the actual tool. So you can see the search box at the top. We've just put some branding in there, and he's got an OpenStreetMap base map to run under it. And you can filter by name, you can filter by category, and then you can choose the birth date of the person as a date range as well, as a means of viewing or filtering the type of plaques that you want to be seeing. Now I'll actually dive into the web tool. So this is the web tool, and I've just put in a bit of a search for some plaques that relate to politics and administration for people born between 1800 and 1880. And it's filtered that, and it actually auto extends to the extents of the results, which is pretty cool. So I go ahead and click one, and it provides, he's put in a window that, yeah, has the thumbnail or the trim down, I should say the trim down plaque from the geo box, the bounding box, I should say, and they've just put category, years, and born as the main attributes. And then the ID, so that was a UUID generated in FME. And then there's a more info tab as well that actually links you to some more information. So in those parameters that we've got in the search box, they're all essentially GET requests that we've built in data virtualization, and then those data virtualization workflows are designed to retrieve or filter down that database that we've just built with the AI in Spatial Light. And the URL, I guess, that's delivered for more info. Within that more info link is actually a workspace that's run as a GET request that produces a PDF it basically just selects it down and matches it with the ID there, and pulls that in and puts it into a structured PDF. And I'll show you what that looks like in a little bit. And this solution is actually entirely hosted on FME Flow, as I think I mentioned before as well. And this is what the PDF looks like. There's 3 pages to it. The first page is a summary report. Sorry, that's just what the title is, I should say. And this is what the page is like. So it gives you an image of the locations for plaques around as a bit of a converted raster, converted map, I should say. Then that's the second page we've got here, which provides it again and retrieves the biography data that we got FME to create as part of the AI calls, and then it provides the thumbnail as well. And then finally, citations were also asked to be produced as part of the AI call, and we've just put those in as references if people want to go find out more information or where we've got the information from. What we've also done is integrated this to ChatGPT, which is actually not too difficult of a process, because mainly what you're just doing is within data virtualization, there's actually an ability to go over to actions and then export the API into OpenAPI specifications, which you can then take to ChatGPT. And when you go to configure a particular app or an application, you can actually then go to the actions, and you can load in the OpenAPI specification as a model as a source to feed the language model. So that's kind of what it looks like when you go into the schema, and you more or less just copy and paste it across. And yeah, you've kind of created something that you can use API to question the data that you've just built using AI. And this is just a bit of a clearer screenshot of the ChatGPT application that essentially uses the APIs connecting into the database, the Spatial Light, as the information used for any questions that you want to ask through the ChatGPT application. So this is quite a good example, of how you can, using the OpenAI specification template export, how you can actually really fast get things configured and using your data virtualization in other apps, but also you can use it a bit more complex or in things like the HTTP website that I just showed you, that's more custom built and is embedded a little bit differently. But that's the end of this webinar. So I'll give it back to Daniela, who will just answer any of the questions that have come in today.